Hello everyone. So in the last video we solved remove duplicates from sorted array, and in this video we are going to solve remove duplicates from sorted array 2. These two questions are very much similar, so if you haven't seen the last video please go and see it, because the solution of this question remove duplicates from sorted array 2 is very much dependent on the solution of remove duplicates from sorted array. So these two questions has nothing much difference. In this question from remove duplicates from sorted array, we have to remove all the duplicates, but in remove duplicate from sorted array 2, let me first open this. Okay, so in this the only difference is that we have to keep maximum of two duplicates. Okay, so given an integer array sorted in increasing order, remove some duplicates in place such that each unique element appear at most twice. The relative order of the element should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have a result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of num should hold the final result. It does not matter what you leave beyond the first k element. Now we have to return k after placing the final result in first k slots of the num. Do not allocate extra space for another array. You must do this by modifying the input array in place with big of 1 extra memory. Now let's take example first. So as per the question, we have to sort this array, keep all the unique elements at the first place, and if there are duplicates for a number, then we have to keep at maximum of 2 duplicates. So for the first element, we have 3 duplicates. We will keep 2 duplicates and remove this one. Then for the 2, we have 2 duplicates, we will keep both, and for 3, we have it as a single element, so we will keep 3 only. So the total elements are 5, so we'll return the 5. Okay, similarly in the example 2, we have 0 2 times, so we'll keep 0 2 times, 1 as 4 times, so we'll keep 1 as 2 times, 3 2 times, we'll keep 3 2 times, and the total elements are 2 4 6 and 7, so we'll return 7. Now, as I told you, this solution of this question is very much related to the previous question. So in that, the first solution that we discussed is that if we replace all the duplicate elements with an element that is out of range and is largest. So for example, in this question, you can see that the range is minus 10 to the power 4 to the 10 to the power 4. If we put all the duplicates in this array, so for example, this 0 is duplicate. So if we place here 10 to the power 4 plus 1. So if we do, for example, let me show you. So in this array, if I replace the duplicates with 10 to the power of 4 plus 1. So if I replace these duplicates with 10 to the power of 4 plus 1, then what will happen? These elements that we have replaced just now are the largest element inside this array. Now, after placing these duplicates with 10 to the power 4 plus 1, when we sort this array, we are sure that all those non-duplicates will come at the start. So this element, then this element will be here, then this 2 will be here, and this is not replaced. So 3, and all the elements that are replaced by 10 to power 4 plus 1 will be at the end. So these are the unique elements. Now the requirement of this current question is that we have to keep at maximum of 2 duplicates. Okay, so we have to replace, we don't have to replace these two, we don't have to replace these two, but we have to replace this with 10 to the power 4 plus 1. We will replace this with 10 to the power 4 plus 1. We don't replace this, and we will not replace either of these elements as well. So after doing this, we will sort this array, and we will get all our unique elements at the start of the array, and we will return the count of those unique elements. So the first solution is very basic, so let's first implement that, and then we'll go to the optimized version. Now, the solution of this one is similar to this, just we have to add some conditions, and the conditions are very much like we have to skip first duplicate and the second duplicate, and we have to ignore the third duplicate. So let's start implementing this. So we will keep a count of unique elements, and these unique elements are the elements which have at max of 2 duplicates. Okay, and the size will be nums dot size. So we'll skip elements, and the skip is initially 1. Okay, now for 0 I is less than sj minus 1 and I plus plus. Sj minus 1 because we will compare ith element with I plus 1th element. Okay, so if nums at I is equals to nums at I plus 1, then what do we do? These two elements are same, so we will skip this element. Okay, and continue. If the skip count is less than or equal to 2, then we will skip this and move on to the new iteration. Okay, else now if we have already skipped the two elements and now the third element come which is also similar to the next element, then what do we do? Then after skipping two elements, we will increment the count. So this count element represent how many elements we eliminated from the whole array. So for example, we have 3 copies of 1. So we'll have to eliminate 1 from this array. So that count will tell us how many elements we have eliminated from the whole array. And finally, we will return size minus count, which will give us the elements that we kept inside the array. So we'll increment the count and replace this element ith position with 10 to the power 4 plus 1. Okay, so this will be the largest element inside this array. Else if these are not same, then we will restore our skip count. So we'll restore skip is equal to 1. After doing this, we are sure that we have kept at maximum of 2 duplicates for each number, and we replaced all the other number with the maximum of 10 to the power 4 plus 1, that is out of range of nums I element. Okay, now we have to return the unique element, so we'll return that is size minus count. These are the elements, but we also have to order those unique element at the start of the array. So for that we have to sort. So nums dot begin and nums dot end. So what we did here, first we replaced all the elements that we don't want with 10 to the power 4 plus 1, that is an element greater than element that comes inside this nums, and we also counted how many elements we eliminated. After this elimination, we shorted the array so that all the short elements or the smaller elements will be ordered and come in front of the array. Finally, we will return total elements minus the elements we eliminated. So that will give us the unique count of the elements. And our initial test case has been passed. Now we will submit this and see whether it can pass all the test case or not. And our solution is accepted. Now let's see this approach 2. So let's see second example for the approach 2. Okay, so first, if you've seen the last question answer, the second approach, first I'll be telling you the second approach in brief, and then I'll move forward with the second approach. Okay. So in the previous, what we did was we created two elements, I, which is the starting pointer. So here it will be 0, and then j, that will be equal to 1. So I will tell us the unique elements. So all the elements at position I and before it are unique elements, and j will give us the next unique element. Okay. So for example, if our I is here initially and j is here. Okay, so I and j are equal, which means the element at position j is not unique, right? So we will move, I will stay at here, but j will move on to the next position. So j will be now at second position. Okay, Now what? So j is now here. Now I and j are not equal. This means that the element at position j is unique. So what will we do? So we will replace the element at I plus 1th position with jth position. So here we'll replace this element with element at position 2, that is 1. Okay, now we will move forward both I and j. So I will be 1 and j will be 3. Now we'll see at position 1 and position 3. So at this position and this position, the elements are same, which means the element at position j is not unique. So we'll move forward j to the next position. Now we'll compare with this position. So we'll see that these two elements are also same, which means the element at position j is not unique. We'll move forward. Again, we see that the element at this position and this position are same, which means the element at position j is not unique. So we'll move forward. Now at the position index 6, you see the element at index 1 and 6 are unique. So which means the element at position j is unique. So we have to consider it. So we will place this element at I plus 1th position. So at this position, we will place this element 2. So we'll place element 2 and now move forward I and j. So I will be 2 now and j will be 7 now. Now you see element at position index 7 and at 2 are different, which means element at index 7 is unique. So we will place this element at I plus 1th position. So we'll place this element at here and move forward I, that is 3 now. So and j will be 8. Now you see element at index 3 and 8 are same, which means that element at index j is not unique. So we'll move index of j to 1 ahead, that is 9, which is out of bounds. So it is out of bounds and we will skip. So you see our I is at 3, that is 0, 1, 2, 3 here. So all the elements at index 3 and before it are unique and in sorted order. So you see 0, 1, 2 and 3. So our elements will be 0, 1, 2, 3. Okay, so these are our elements and we don't care about all the elements ahead of it. And finally we will return I plus 1. So I is the index which is 0 based. So we have to return the count of unique elements, that is I plus 1. So that is total of 3 plus 1, that is 4. So these are the 4 elements. Now in this question, the only difference is that when we see duplicate element, okay, we have to keep at most 2 duplicates element. So what change do we need here? So the only change is we see if the elements are same. For example, in case of 0 and 0, these two elements are same. Now the only thing we will do is we'll check if these are same and the count is 2. Count means the skip count is 2. Then we will increment the j plus plus. Okay. J, what will j plus plus do? Okay, so we see that if the element at ith index and jth index are not same, we considered that element as unique. And now in this case we will consider element at jth position and ith position unique if the skip count is less than that. Okay, and if the skip count is larger than that and if the elements are same, then we consider that as a duplicate element. So this is the only change that we will do in this algorithm. Let me give you a walkthrough of this question using the algorithm too. Okay, so we'll keep similar elements, that is I will be 0, j will be 1, but the another thing that we'll keep is count, that will be 1. So in this case I is 0, j is 1. And you see I and j, the elements at I and j are equal. The count is not greater than or equal to 2. We have not skipped the another 0. Okay, so at I0, by I0 we mean that the element at position I and before it are unique elements. Okay, but at position j we have to consider whether to keep it or remove it. Now at position j is equal to 1, we have to decide this. So these two elements I and j are same. Okay, so should we keep it or should we move forward? We have to keep it because the count of skip elements is 1, not 2. So we have to keep it. So after taking this 0 elements, we take the 0 element and we say, okay, we are taking this element, but we will increment the count to 2. We'll increment the count to 2 and we will replace the element at I plus 1 position with the element at jth position. So element at I plus 1 is this and element at j is this only. So we'll replace 0 with 0. So these two elements are kept and finally we will move I and j. So I will be 1 and j will be 2. So now at position this and this, these two elements are not same. So if the elements are not same, obviously we will have to do what? Keep the element at jth position because it is a unique element, but also we have to reset the count. So here the count will be reset again to 1 and we will keep the element at this position. So what do? We will replace this element with I plus 1th position. So this is I and this is I plus 1. So we'll replace this position with same element. So nothing will change. Okay. And now we will move forward. So I will be now 2 and j will be now 3. So here we are. This is I and this is j. So now you see the count is our 1 and we see that the element at ith position, jth position are same. So should we keep the element at position j is equal to 3 or not? So we will keep it because the skip count is still 1. So we will take this element but we'll increment this element count, that is skip count, to 2. After skipping, we will replace the element at I plus 1th position with element at jth position. So I plus 1 is this element and we will replace it with itself. So nothing will change. Now we will increment I with 3 and j with 1. So now we are here. Now you see that element at I and j are same. But should we skip j? So you see the skip count is already 2. We will not keep this element again. So we will increment j to 1 position ahead. So now j will be at this position. So I is at this position and j is at this position. Okay, so I is at 3 and j is at this position. Now I and j, element at I and jth position are still the same. So should we skip the j? Yes, we should skip because the skip count is already 2. So we'll increment j to the 1. Now it will become 6. So j is at this position. Now you see the elements are not same at ith and jth position. So if elements are not same, we have to keep that element because j will give us the unique element. So at position j, the element is unique. So what do? We'll replace this with I plus 1th position element. So I is this and I plus 1 is this. So we'll place this 2 at this position and reset the counter. Okay. Now we'll move I forward and j forward. So I will be this and j will be this. So now the element at I and j positions are not same, which means we have to keep this element. So we will place the element at position j at I plus 1 position. So I plus 1 position is this. So we'll place 3 here. Okay. And after placing this, we have to reset the counter, that is already resetted, but we have to reset again. So that is 1. Now we will move forward I and j. So after moving forward I and j, I will be at this position and j will be at this position. Now you see element at I and j position are same. Should we keep it or should we move forward? We should keep it because the skip count is 1. So we will take this element. So we'll place this at I plus 1th position. So I is our 5. So we'll place this element here. So we'll place element 3 here and move I and j forward. So I will be 6 and j will be 9. Now the j is out of bounds and will be out of the loop. So now you see I is 6. Okay, so that is 0, 1, 2, 3, 4, 5, 6. Our I is here. So what does this I represent? So in the previous question, it represented the element at ith position. All the before it are unique elements. Similarly, here also it represent the element at ith position before it are unique elements. The only difference is it has at most two elements duplicates for each element before it. Okay. So I is our 6. So 6 plus 1 means there are total 7 elements that are duplicate here. So 2, 4, 6 and 7. And these are 0, 0, 1, 1, 2, 3 and 3. So these are the unique elements. Okay, so now let's implement this. So these two elements I will be 0, j will be 1 and size will be nums dot size. We'll keep skip count to 1, and while j is less than sz, because I will always be less than sz, so we don't have to do that. Now we write bool is same. If this is same at I and j, will do if is same and the skip count is greater than or equal to 2. We don't have to consider this. We will move forward. The element at jth position is not unique. But now we check first. Let's replace the element with I plus 1th position with the element at jth position, and now we will increment I and j. Okay, but here also when we include this unique element inside the array, we'll have to reset the skip counter, right? But if the element that we have included is duplicate, then we have to increment the counter also. So if is same, then what do? We'll increment the skip counter, else we will reset the skip counter. Now finally, after doing this, we will return I plus 1. Now let's see if this works or not. So our initial test case has been passed. Now we will see whether it can pass all the test case or not. And our solution is accepted. So let me recap what we have done. So in the whole array, we check if the elements are same. Now if the element is same and at jth position, we have already skipped two and more elements. Two or more elements we have already skipped, then we will move on to the next element. So we don't have to write like greater than 2, we'll just simply write equal to 2, but that's fine. So we will move on to next position, because at jth position this element is not unique. Else what we do is we will place the element at jth position at I plus 1th position. After placing this, we will increment both I and j. But before that, now if element at I and jth position are different, okay, which means we have to reset the counter. But if the element at I and jth position that we just included inside the array are same, which means we just included another duplicate inside our array, so we will increment the skip count. So that's the whole logic of this problem, and that's the end of this question.